An atom becomes an ion by losing or gaining electrons. This isn't like when I lose stuff. They do this deliberately to achieve a full highest energy level, with no gaps or no spare electrons hanging around. This leaves the electron structure the same as that of a noble gas. Classy. For metals, the simplest route to a full highest energy level is to get rid of the few spare electrons they have on the outside. Goodbye atom, hello ion. For non-metals, on the other hand, the best route is to take on more electrons to fill the gaps in their highest energy level. In atoms, there are equal numbers of protons and electrons, but in ions there is now an imbalance. This gives them an overall electric charge. Some are negative, others are positive. Metal atoms such as sodium and aluminium lose electrons and become positively charged ions. Non-metal atoms like chlorine and oxygen gain extra electrons and become negatively charged ions. Let's look at some examples. First, let's look at metal ions. Sodium has 2 electrons in the innermost energy level, then 8, and finally 1 in the highest energy level. To become a sodium ion, it loses the electron from its highest energy level. Ruthless. You see? Metal ions. Nerves of steel. The diagram of a sodium ion is very similar to neon, but they are not the same thing. Remember, neon has only 10 protons in the nucleus, whereas sodium still has the original 11. Always check the nucleus. 11 protons versus 10 electrons. The extra proton gives the sodium ion an overall 1 positive charge. Sodium 1, neon 0. Now, magnesium is another metal, but this time with 2 electrons in its highest energy level. To become a magnesium ion, it has to lose both of these. Rules is rules. We use a 2+ to show this. That might sound contradictory, but with 2 negatively charged electrons gone, that gives the magnesium ion a 2+ charge overall. Because metal atoms lose electrons from their highest energy level, the number of charges on a metal ion is the same as the periodic table group number for that metal. No way! That is so spooky. Check this out, I am freaked. Non-metal ions gain electrons. Take fluorine, for example, in group 7. It has 7 electrons in its highest energy level. It takes 8 electrons to fill that energy level, so it needs to gain 1 more to become a fluoride ion. Well, if that's what it takes to get toothpaste. Again, looking at the diagram of the fluoride ion, it is remarkably similar to neon, but neon has 10 protons and the fluoride ion just 9. It's important not to get the two confused. 10 negative electrons and 9 positive protons leaves fluoride with a net result of 1 negative charge. We write a minus sign to show this. Oxygen, in group 6, is another non-metal, 6 electrons in the highest energy level. So to make it up to 8, an oxygen atom is going to gain 2 electrons to become an oxide ion. The oxide ion has a 2- overall charge. The position of the non-metals in the periodic table tells you how many electrons they need to fill their highest energy level, which tells you the charge on the ion. So where do the electrons come from or go to? It actually works out at a fair exchange. The electrons leave the metals and join the non-metals. They're all happier that way. Truth is, it's all about bonding. The positively charged metal ions and the negatively charged non-metal ions strongly attract each other. For example, sodium bonds with chlorine to form sodium chloride. Magnesium bonds with oxygen to form magnesium oxide. There is a strong electrostatic force of attraction between these oppositely charged ions. This is called an ionic bond. One of the things you will need to be able to do is draw a dot and cross diagram to show the ions in some common ionic compounds. Take sodium chloride, for example. Draw the metal ion, in this case sodium, using dots for the electrons. Draw the non-metal ion, chloride, using crosses. The electron that is transferred to the non-metal is shown as a dot, indicating clearly that it has come from the metal atom. Make sure to use all the electrons. Here is magnesium oxide, for example. Sometimes the chemical formula for a compound includes uneven numbers of atoms. Nothing's ever simple, is it? For example, calcium chloride is CaCl2. It has 1 calcium ion and 2 chloride ions. You need to show the correct number of ions. The chloride ions have 1 electron each from the calcium, which is how they bond. So that's all you need to know about ionic bonding. It's all about full energy levels, charges, and attractions.